Hello everybody, welcome to the part 2 of the series on making legacy code safer using modern C++ techniques. In the previous video I talked about how the use of std.chrono improves safety when interacting with legacy code. In this video we are going to focus on how providing custom functions to smart pointers ensures better and more efficient memory management in comparison to legacy code. The function passed to the smart pointers to clean up the memory resource at the end of their lifetime is most commonly referred to as the custom deleter. But, first of all, before we start, what are the problems we are trying to solve? When working with older libraries, we might end up owning row pointers or other types of resources that need to be cleaned up properly. In most C-written libraries, objects are created using specific functions and require other specific functions that do the actual cleanup to be called when the object is no longer needed. Handling row pointers is normally error-prone. Improper handling can result in a series of bugs such as memory leaks or runtime crashes due to double freeze. Modern C++ features allow us to avoid such issues by providing better control over the lifetime of these resources. In modern C++, there are currently two smart pointers, called smart because they clean up the resource once it is no longer needed, std_unique_ptr and std_shared_ptr. They make use of the resource acquisition is initialization programming idiom to clean up a resource once they are destroyed. A pointer stored within std_unique_ptr can have only one owner, hence std_unique_ptr cannot be copied, only move. Move operation allows therefore for the owner to be changed. As such, once std_unique_ptr goes out of scope, it cleans up the owned resource. A pointer stored within std_shared_ptr on the other hand might have multiple owners. std_shared_ptr internally stores the number of current owners. Once that number reaches 0, the respective resource is cleaned up. Both of these classes have a method that is called do the cleanup when the owned resource is no longer needed. The method can be a lambda or an object that just has the operator parenthesis method defined, as this will be the only invoked. By default, std_default delete is invoked. This calls either delete or the other delete operator, depending on the respective resources type, array or not. For our examples further, we will use the std_unique_ptr, but the same applies for std_shared_ptr. One implementation of std_unique_ptr might look like this, having a deleter type object provided as the second argument for the template it constructed. Let's consider we have a library that handles our communication with a database. We might have a db handler type object that is responsible for the communication defined as here. It stores the last request, a timeout for the queries, and a configuration pointer. Libraries also offer a configuration struct based on which the handler is constructed. In most cases, the library typically provides a specific function for handler construction, in this case called dbnew. As such, the function responsible for constructing the handler will also take the configuration conf as parameter of which it will take ownership. That's important. Once the handler is no longer needed, we have to call another function to free the memory of both the handler and the config to the operating system, in this case called dbdestroy. An example of a method using the database handler would look something like this. So we create a new configuration pointer, we create a new handler, we do our stuff, and then at the end we destroy it. However, in this code, the program might throw an exception and we never get to the dbdestroy call to free the memory, hence we get a memory leak. If we consider this function is called a few times a second, leaking a small amount of memory on every call, we might run out of memory in a very short amount of time. Another problem might arise when we have an if-else condition with multiple exits. We would have to make sure that we call dbdestroy on each exit point. So we have to call it here, we have to call it here, and if we don't, there's a memory leak like in this case. So how can we use mic pointers to make this type of code safer? Unfortunately, we cannot just replace the row pointers with mic pointers. We cannot write code like this. The handler pointer in this specific case will be free to write once in dbdestroy and once the unique ptr goes out of scope, resulting in the runtime failure of double free. So if we just call this function here and run it, now it will result in the runtime failure of double free. If we remove dbdestroy on the last lines, it will result in a different bug. This time the program will run. However, the memory of config will not be free. dbdestroy frees both the config and the handler. The correct version would look something like this. And let's also call this function. Let's see this program compiles. it compiles and it runs. We first create a function called destroy fn that accesses as input a db handler type pointer, and all it does is call the appropriate library function to clean up the object. Afterwards, we create a std unique ptr by specifying that function as the second argument. In case of std unique ptr, we also have to specify the function pointer type in the template list. Note that we could have also directly defined the lambda in the creation of the std unique ptr. Something like this. Well, now, when the std unique ptr goes out of scope, it to call our function to clean up the owned internal resource rather than std default delete, the default deleter. It is not complicated. On the contrary, it simplifies the code and brings a lot of advantages and safety with it. As such, using smart pointers, the aforementioned problems that we had by dealing with raw pointers are now gone. If an exception is thrown, the std unique ptr goes out of scope and the handler pointer is automatically cleaned up using the appropriate function. The premature exit conditions are perfectly handled as well and do not result in a memory leak. For a concrete example of where the use of smart pointers would help in dealing with C libraries, let us consider the libcurl library, on which curl command in Linux is based. With no custom deleter, part of the code would look like this. We have a function that does HTTP requests. In this function, we have two pointers that have to be managed by us. The curl handler, a handler to be used in every libcurl function, and header list, a linked list of the HTTP headers to be passed to the HTTP server. Curl easy init initializes the handler and must have a matching curl easy cleanup call at the end. The same goes for header list. We must call curl slist free all to free all elements in the list, each containing a header value. In case of multiple exit points or potentially foreign function, we can end up easily with a memory leak. As previously mentioned, just imagine do HTTP request is called 5 times per second, each time leaving a chunk of memory not cleaned up. Using smart pointers with custom functions for cleaning up objects, we can significantly simplify the code above. There is no need to pay attention to call the right functions for the two objects, the handler and the header list when exiting the code. As such, the chances of making mistakes reduce drastically and the code complexity decreases. We now have unique pointer for the curl handler, which has the custom deleter, and a unique pointer for the header list, which also has a custom deleter that accesses slist pointer as parameter. There is no need to call the other functions at the end. Excellent. We have avoided potential memory leaks or crashes. Note that these functions can also be declared separately and reused in all needed places. Thank you for watching to the end, and I hope you learned something new. Please let me know in the comments what other modern C++ features can be used to improve safety, how this video helped you, or how it can be improved. If you liked what you saw, don't forget to like and subscribe, as I'll try to post stuff about interesting topics as often as possible. Thank you very much, and see you in the next video.